This is a very, very simple drawing of curtain antenna. What you have there is basically in this picture, you have 3 horizontal dipoles on each set. This is a 2-bay, I guess we call it a 2-bay curtain. And so you have actually 3 dipoles there above each other on each other. But what you have, a dipole may not necessarily be a halfway or a whole way. That again has been determined by what you want in gain, what you need in power to get there. So that it is simply the fact that it's center fit, I call it a dipole. But it's not necessarily a halfway dipole or a whole way dipole. It may be several halfways. In fact, they usually work. And then notice also they have 3 above each other in this case. Now some of ours were just simple 2 vertical arrays. And we had antennas that were 4 high and 3 wide. But now we also have, in order and that is determined by what we put in there, is determined by what it took to get to that target audience. The angle of takeoff, you could change the angle of takeoff by the way you phase these arrays. And for instance, if you were on a flat ground, your antenna had one angle of takeoff, but one of my antennas, one being to North America, was a 3-bay high. And it had a drop-off in front of the antenna. Just went straight out for a quarter of a mile, just downhill. Okay, they had to phase that to bring that signal up, so it would go out across the mountain out there. And they did that by phasing. But then there's another aspect of this, and that is the reflector. Now all these curtain antennas have reflectors on them. Now I drew a reflector down here just to show how they're constructed. That is a wire screen. And those elements have to be, the length is critical. And I never designed it, but I think it's a 1/10 of a wavelength on the highest frequency. Something like that. 1/10 of a wavelength on the highest frequency. Because some of these antennas are broadband enough you can operate them on 2 bands. For instance, on 19 or 21 meters, they often operate them on 2 bands, if needed be. And then they would put this, let's see, okay, if you look at this picture here, you notice their towers are in pairs. Well, in the case of a simple one-direction antenna, that other pair would be holding the screen. But there was something else they had here. Their location was unique because North America was on this side, South America was on this side. So they could use one antenna infrastructure, you might say, a pole post to the tower or something, with 2 curtains, one on each side. And they would make them double width, I should say, and hang the reflector suspended between the 2 rows of towers. And then have on this side have one antenna operating completely independently from this one. They both be on the air at completely different frequencies, and the reflector screen showing the reflectors of both of them. We have two conditions like that. We have North and South America for what we call the North and South America array, and then we have down here. This is the North and South America. Down here, you have the Europe and South Pacific array, and that was the same way. That was the big array. Europe and South Pacific. Those were 4 high and 3 wide. And with a ground screen hanging in between. Then in addition to that, we had let's see, some of the other antennas, we had cubical quad, which, by the way, was built in Elkhart, Indiana. I happen to have worked with it and worked on it at Elkhart, but my boss built it and then stripped it. He had formerly been an engineer with HCJP. And it was a 6-element, 4-bay, 24 quad elements on big tower. And that was on 13 meters, just above the 15-meter band. Then we have a Romney antenna. That's a simple Romney. I built that in a fun project.